All right, today we are going to be talking about unit cubes and solid figures. And our essential question is, what is a unit cube and how can you use it to build a solid figure? All right, so we're going to start off by talking about a unit cube. And a unit cube is a cube that has a length, width, and height of 1 unit. The first thing we're going to discuss is some of the features that we have when we're talking about cubes and really any rectangular prisms. So we have on a cube, we have faces. And a face is any flat surface that makes up part of our three-dimensional shape. So when we're talking about cubes, we get one face here in the front, two face here on the top, three on this side. We also are going to have one back here in the back. We're going to have a fifth one that makes up this side. And then down here on the bottom is going to be our sixth one. So all cubes, and really all rectangular prisms for that matter, have 6 faces. With a cube, those faces are all going to be square, and because they are all square, they are all going to be congruent. That means that they're all exactly the same. Another component of rectangular prisms and three-dimensional shapes are these sides right here. So any place where two faces intersect, we get what is called an edge. So if we take a look at a cube here on top has 1, 2, 3, 4 edges. It means down here on the bottom, it's also going to have 4 edges. And then each of these corners are going to be connected by an edge as well. So 4 for the bottom plus 4 for the top plus 4 around the sides is 12 edges. So another thing is because these are all squares, all of these edges are going to be equal. A final component of prisms is that if we look here, we have all these kind of pointy corners, we might call them, right? So any place where edges intersect, these are called a vertex. And if we have multiple of them, then we just change this to a vertice. So faces, edges, and even though they don't require it, vertices. Let's talk for a second about the impact that the size of our unit has on our cube. So here I've made models of 3 different cubes. This biggest cube right here is 1 cubic foot. So that means that this side, this side, this side, all of these edges are equal to 1 foot in length. This one right here next to it, this one has a volume of 1 cubic inch. So that means that each side, each edge, is 1 inch in length. And then this tiny, tiny one down here, this one is 1 cubic centimeter, right? So 1 centimeter by 1 centimeter by 1 and 1, right? So 1 centimeter for all of those. So hopefully what you can see by looking at this is that when we increase the size of our unit, right, so going from centimeters to inches and inches to feet and inches to yards and so on and so forth, the size of our cubes get really, really, really big. Like this is more than 12 times bigger than this. It's 12 times across bigger, plus 12 times taller, plus 12 times deeper. All right. Up next, you are going to do your best to try to build as many different rectangular prisms as you can using 8 unit cubes. Now, hopefully you have something at home that you can use for this. If not, that's okay, just do your best. And we'll come back and we'll look at this at the end of the lesson and see how many different rectangular prisms we can make with 8 unit cubes. And just one idea to keep in mind is that if we draw a rectangular prism that goes like this, right? Right? And then and let's say that this is, I don't know, like 2 by 2, who knows? Anyway, if we take and we draw this shape, and then we were to take it and stand it up on edge, that's really not going to be a new rectangular prism, right? So if we do a 1 by 8 by 1, that's no different than an 8 by 1 by 1 or a 1 by 1 by 8. All of these are basically the same prism. So just keep that in mind as you're working through that activity. All right. So the other component of our lesson that we need to work on today is that we need to figure out how to identify volume of solid figures by counting up our unit cubes. This is really going to be surprisingly simple because all we're really going to be doing is counting unit cubes. So if we look at this shape right here, even though it's not a rectangular prism, it's still composed of unit cubes. And we have our 1, 2, 3, 4, 5, 6. It's like they thought you couldn't even count on your own. But we can see here that figure 1 is made up of 6 unit cubes. Try another one here. So this one, figure 2, is made up of 5 unit cubes. Again, we could count them up. We would see that there are 1, 2, 3, 4, and 5 unit cubes. And we can compare these cubes together, and even though they have different shapes, because they're made up of unit cubes and because we found the volume of those, we can see that figure 1 has more unit cubes than figure 5, and so figure 1 is a larger shape. It takes up more volume. All right, these we actually have to count on our own. Oh no, can you do it? I think you can. Here we see that this shape is made up of 1, 2, 3 unit cubes, and this is in fact a rectangular prism. Remember, rectangular prisms have congruent bases, and the sides are connected by rectangles, so this one is a rectangular prism, and it's made up of 3 cubic units. Take a look at the next one here. Here, another rectangular prism. Across the bottom, we can see we have 1, 2, 3, 4, 5 units. Now we could count all of these, but if we know that across the bottom we have 5 cubic units, we also know that this row is going to have 5 cubic units, and this row is also going to have 5 cubic units. So we could say 5 plus 5 plus 5 is 15, or we could say that we have 3 rows of 5, and 3 times 5 is 15 cubic units. Our last one we're going to look at on this page is right here. Again, we're going to look at this one and see that across the bottom we have 4 units, and then we end up with 3 rows of 4 cubic units. So 3 times 4 is 12. So here we have 12 cubic units. Hopefully what you're starting to see is that when we're talking about rectangular prisms, right, instead of counting every single unit, we can start to get to this point where we are going to incorporate some multiplication into finding volume. Let's take a look at this one here. Now with this one, it's important that we recognize that there are units that we can't actually see. And we just have to assume that they're not like playing tricks on us and that there are actually a couple more units here in the background. So we need to figure out how many. So we're going to take a look at this website. And what we can see, and this is a model of that same exact rectangular prism, right? So what we can see is that the bottom, our base level, is made up of 3 units by 2 units. So if we add a layer in here, right, we get 1, 2, 3, 4, 5, 6, because 3 times 2 equals 6, right? So the area of our base is 6 square units. Now, as we give our shape depth, right, as we add our third dimension, right, like right now it's 1 unit high, which, doesn't change anything. So if we multiply 6 times 1, right, we still get 6. And remember, to have a 3-dimensional shape, we can't just have length and width, we also have to have height, but hopefully what we can see is that length times width is the same thing as area. So if we find the area of the base of our shape, then we add our layers, right? So if we take this and we pull this back off, right, we can see here that we have 1, 2, 3, 4, 5, 6 square units on the bottom. And then every time we add a layer, we add that third dimension of height to it. So now this is 3 by 2 by 1, which means that it would be 6 cubic units. Then if we add our second layer, now we see that it is not by 1, but it is multiplied by 2. So this shape has a volume of 12 cubic units. And this is a really fun website, and I will put a link to it in our lesson description so that you can play around with it as well. You can go up here and change the size of your shape and do all of that kind of stuff, which is important to kind of take a look at, right? Because if we take a look at this, if instead of making it a 3 by 2, now it's a 2 by 3, now it is a 2 by 4. So the area of this base is no longer 6, but is instead going to be, we'll just cross all this off so we don't get confused, right? But is going to be 2 by 4, and then it's still 2 units tall, right? So 2 times 4 base area is 8 times 2 to get my volume is going to be 16, right? And if we take this and fill in each cube, 1, 2, 3, 4, 5, 6, 7, 8, right? Remember, 8 units on the bottom. And then we have 2 different layers, so we get 16 total units, right? 8 plus 8 is, in fact, 16. And if we take it and close it up, it closes up nicely. All right, so back to this one. Again, if we count them all up, we can see that we have 1, 2, 3, 4, 5, 6, 7. There's a hidden one in the back here for number 8. There's another hidden one in the back here for 9, 10, 11, and 12 total units. All right, let's compare a couple of solid figures, and then we're going to be about ready to wrap this lesson up. All right, so the one on the left here, we see that we have 1, 2, 3, 4, 5 unit cubes, and the one on the right, 1, 2, 3, 4, with the fifth one sitting on top. So in this case, these two are equal. All right, let's look at this one. So here we have the Nagakin Capsule Tower, and it says it has 140 modules and is 14 stories high. If all of the modules were divided evenly among all of the stories, how many modules would be on each floor? How many different rectangular prisms could be made from that number? So we're going to kind of skip the last part there because that's just more than I really want to take on right now. But I do want to think about this idea of how many modules would be on each floor, right? So that's our question. So the number of modules on each floor, and we want to divide them up evenly. So we know that there are 140 modules total. We know that there are 14 floors, right? So if we think about this in terms of unit cubes, so this is 140 cubic units, right? Divided into 14 layers, right? So kind of thinking back to that idea of the base area times the height will tell us, right, like how, what our volume is. So if this is our height, right, and this is our total area, then if we just want to find our base area, if we divide 140 by 14, right, that is 10. So that means that there are 10 units per level, right? Because if we had 10 units on each level, and it's 14 units tall, I'm sorry, 14 layers tall, that's going to be 140. So the answer here is 10 units. All right, moving on to the end of our lesson. I asked you to take a look at that question about building as many different rectangular prisms as you could from 8-unit cubes. And so let's take a minute to think about that and see how many we can come up with. And let's go ahead and look back at this idea, and let's see if we can use it to help us, right? So if we want to use 8-unit cubes, right, one thing we could do is we could stack them all in a row, right? So that is 5, 6, that one didn't quite go where I wanted it to, 7, and number 8, right? So there are 8 laid out like that. Now remember, I told you that just because we can, like just taking this one and like rotating it around till it's standing up like that isn't necessarily a new rectangular prism. So we're going to count that as number 1. Let's see if we can come up with another one. So if we take and put one here and we put one beside it, right? Now, instead of going out, we could start to go up, right? So here we end up with 6, 7, or 8 ends up being right there, right? So this is a 1 by 1 by 8. This one is a 1 by 2 by 4. Let's see, can we come up with any others? Let's slide over so we have enough space. Let's go ahead and paste in another one, right? So what if we go too tall, right? And then we also go back here and we go too deep, right? So now we have a 2 by 2 by 2, right? So that's going to be 8. Are there any others? Are there any more? I don't know. You email me and let me know if you come up with some other rectangular prisms that fit this description. Now, remember, even though we looked at some different composed figures in our lesson today, they're asking for rectangular prisms, which mean that our bases have to be congruent, right? So we couldn't, for example, take this one and go out 4 and then make an L shape because that would not fit the mold of that rectangular prism. But we'll go ahead and record them right here just to make sure that we have the ones that we did get. So we got a 1 tall by 1 deep by 8 wide, so 1 by 1 by 8. We also got a 1 by 2 by 4. We also got a 2 by 2 by 2, right? And remember, if we multiply all of these together, they're all going to equal 8. 1 times 2 times 4 is 8. 2 times 2 times 2 is 8. So when you think you have one, make sure that you multiply it, all of the side dimensions together. If it doesn't equal 8, it doesn't fit this group. So give it a try, see how it goes, and good luck.